I'm listening.
Oh,
Oh,
oh, never mind.
that was fun. I don't know what that's doing, but it did a thing. Cool. Well, I found a way that I can pull it back up. I love when my technology is grumpy. Okay, so let me capture screen. All right. So we are going to be in our notes. So we're going to be working with another kind of special function called an absolute value function, which I'm going to go back here and write it, and then I'll just capture it. Okay, cool. I have a plan, because this has been super fun to try and figure out during my first year, trying to get all this to work properly. So much fun. All right, so absolute value functions. You've seen absolute values before, but probably not since Algebra 1, maybe earlier. Okay? And absolute values I'll make that a little bit skinnier so you can read it. That's when we use the vertical bar, and we'll usually put like an X inside it or something like that. So what an absolute value function is a graph that relates, so puts in relationship X and Y, a number, which we will be using our X, with its distance from 0. And its distance will be our Y. Which I know feels super weird. Like, why do we care about its distance to 0? And honestly, the best way that I can think of to come up with an example for us to think about absolute values is I'm going to think about a number line. We're going to put a 0 in the middle, just like we typically do. And then I'm going to put a couple of things over here. I'm going to put maybe a positive 3 and a negative 3. Because when we're thinking absolute values, I think about my Apple Watch. If I start at 0 and I take 3 steps this way, how many steps did my watch count? 3 steps. If I start at 0 and I take 3 steps that way, how many steps does my watch count? 3. It doesn't care that I went the other direction. I take 3 steps that way, I take 3 steps that way. I can take 3 steps that way, I can take 3 steps that way. It doesn't matter. It's counting how many steps. So that's what absolute values are doing. Absolute values are your Apple Watch or pedometer app that you use. So the way we could write that is we know that the absolute value of 3 is 3. It's 3 steps. That's what we took. We took, bless you, 3 steps. And we did very similarly for our absolute value of negative 3. We also took 3 steps. So the absolute value of 3 is 3, and the absolute value of negative 3 is 3, because they're both 3 steps away from 0. And we're going to graph these today. gonna be grumpy for a second. Oh, hang on. Sorry, getting back to it. Save. Sorry, it's being grumpy. I'm getting back to it, I promise. There we go. I got it. There we go. So if you needed a little bit more time to write, I've got it. Okay. Okay. So we're going to work with this a little bit. So we're going to look here. There we go. So we have a request here to graph f of x is the absolute value of x. And we're going to approach this just like we did the piecewise in the bell work. I'm going to make a table. We're going to pick some x's. We're going to run it through the process. So I'm going to make us a t-table. We're going to pick some x's. We're going to find some y's. We're going to plot them up. I need, with our graphs, whenever we're doing graphing, I really need a good view of the middle of what's happening. So where is the middle of our graph? What's our x value for the middle? Oh, I should probably give you guys graphs. Huh. What is a good number that would show you the middle of a graph? 0. So in our table, we're going to put a 0 in the middle. And when in doubt, that's a good place to start. I'm not saying that's going to always be where we start, but when in doubt, it's a good place to start. All right. I was going to say, there's usually at least 2 in the boxes.
Yeah, we got 3. She just can take changes.
Like, if it doesn't fit back in the box, just give it back to me, because I need to make sure I get things tidied up. I've been doing a lot of cleaning up after people lately. All right. So we noticed that 0 is a good place to start. So we're going to start with 0 in the middle of our little table here. Because we want a good view of the middle. I'm going to need, very similarly, I need some numbers smaller and I need some numbers bigger. What are some numbers smaller than 0? -1. -2. What are some numbers bigger than 0? 1 and 2. 4 and 5, technically correct. Might make your life a little harder. You did? What's up? Yep, I'm holding on. So, these 5 numbers we have up here, I'm just talking. I'm not writing, I'm just talking. These 5 numbers are going to be our very bestest friends this year. Most of our graphs, we're going to have these numbers on there. Yes. Yeah, a couple more glue sticks. If any of the glue sticks died, throw them away. These 5 numbers, we are going to use a bunch of times. Most of our graphs will have these in them. And I promise I will show you how. But most of our graphs will use these 5 numbers all year long. So these are going to be our new bestest friends. From -2 to 2.
What?
what we're going to do today is we're going to just do it kind of plug and chug style. We're not going to use anything fancy with this. We're going to substitute it in and see. This does work. It's just not always the easiest. This one's not too bad. The drama. Oh my gosh. All right. So what we're going to do is we're going to take our y equals the absolute value of x. Remember, f of x is just y dressed up in disguise. He's got a fancy mustache. So this is y equals the absolute value of x. If our x is negative 2, and we have the equation y equals the absolute value of negative 2, what is my y going to equal? Positive 2. Because the absolute value of negative 2 is positive 2. Boop. So then we're going to do the same thing, working our way down the table. Y equals the absolute value of negative 1. So what is the absolute value of negative 1? Just 1. It's like, be careful about just thinking the opposite. And I'll show you why here in just a second. Y equals the absolute value of 0. What's the absolute value of 0? 0. Next one is that y equals the absolute value of 1. What is the absolute value of 1? Positive 1. So that's why I didn't want you to think opposite. It's a positive 1. What is the absolute value of positive 2? Positive 2. It's 2 steps away from 0. So this gives us a list of points to plot. So we're going to plot up our points. I've got my negative 2, positive 2, negative 1, positive 1, 0, 0, 1, 1, and 2, 2. This looks awfully familiar. What's up? Where'd I lose you?
Okay, so I'm understanding okay, so y is the positive value of x.
Uh-huh.
So I'm understanding that. So what is this?
These over here?
Yeah.
That was just our workspace.
Okay.
It was just me writing down how we figured those out. We are just taking our x's and substituting them in. This is just me, and then the green one is this one, the pink one is this one, purple one is this one, pink one is that one, and I didn't write the last green one. So now we're going to connect these up. What shape are these making? A V, not a U. A V. There must be a point. It is important. Absolute values are shaped like V's. So we have a thing that goes here. And we have a piece that goes here. So if I line that up properly. My iPad is in such a mood today. Oh my gosh. All right. So our graph should look like this. This looks a whole lot like, hang on a second, I'll get back where I can see it. Ah. There we go. The bell work? And what we just graphed? They're the same graph. So this piecewise function is the exact same as the absolute value function. They mean the same thing. That's why this is in here with these piecewise functions. Absolute values are just fancy schmancy piecewise functions. So the next thing that we're going to do before we go on and try this again is we are going to find our domain and range. Because we need to practice this more. So, what is our domain going to be? What is our domain going to be for this? From negative infinity, as far left as we can go. So this is going to go from negative infinity, because this goes as far left as we can imagine, all the way to what? Positive infinity. This will be the most common domain we write all year long. Not going to say it's everything, but it's a lot of things. Our ranges will change. So, what is our range here? What is the very lowest it goes in the y values? 0. What is the highest it goes in my y values? Infinity. Infinity is an idea, so we can't touch it. We put a parenthesis on it. Do we have a point where my y equals 0? Yeah, we sure do. So that's when we put a bracket on it. Because I can equal 0. It's this point here. I can put my laser pointer on it. Ta-da, it's right there. It's also in my table right here. Okay. Questions on this one so far? What's up? What's up?
Domain is left to right.
Left to right.
Range is up and down.
Range is up and down. And it's always smallest to largest on both of them. So my smallest is 0, my largest is infinity. On my domain, my smallest is negative infinity, my biggest positive infinity. Always smallest to largest. Okay? We're going to try this again. Which means I'm going to have to do some switching. Desktop. We're going to go that one. Okay. So this is our next one. Now it's got some extra things, but we're going to approach it the exact same way. This is my function rule. F of x, which is my y. I don't like how chunky that is. My y equals 2 times the absolute value of x minus 1. So we're going to make a table. We're going to pick x values to substitute through it to find y values. When x is all by itself inside here, we're going to start with 0 in the middle. I will show you what we do when we don't have 0 in the middle in just a second. But if x is by himself, we're going to have a 0 in the middle. It's just how that works. If x is by himself inside our absolute value, we start with a 0 in the middle. This should always be the point of our v. So we need a couple of numbers smaller than 0. What can we use? -1, -2. What are a couple numbers bigger than 0? 1 and 2. If we pick the numbers pretty close to that center, without going too far out, we should stay on our graph. And then what we're going to do is we're going to take our x's that we've picked and substitute it into this equation to find our y values. So I'm going to work it to the side over here, kind of like how I did on the last one, but I will explain with more words this time. So we're going to have our y equals 2 times the absolute value, and I'm going to substitute in my x here, -2 minus 1. Careful, careful, careful. We need to do our absolute value first. Order of operations, we do this absolute value first. It works like parentheses. So what is the absolute value of negative 2? 2. So we have 2 times, because that's what it means when they're pressed up against each other. 2 times 2 minus 1. What is 2 times 2? 4. 4 minus 1? 3. So my y here is 3. Do we see where that's coming from? Okay. Let's do the next one. I'm taking my original equation, y equals 2 times the absolute value of my x. I'm going to use minus 1 this time. Minus 1. So I'm just taking my next x in my table. Order of operations says I do my absolute value first. So what is the absolute value of negative 1? 1. So this becomes 2 times positive 1 minus 1. What is 2 times positive 1? 2. 2 minus 1? 1. Do we see where those are coming from? Why are y'all throwing food at each other? Okay, let's do another one. Working our way down the table. Y equals 2 times the absolute value of 0 minus 1. What is the absolute value of 0? Times 2. Minus 1. Negative 1. So you don't have to write out every step. We're going to get to the point where we can start doing some of it in our brains, hopefully. So we're going to keep going. I've got my y equals 2 times the absolute value of 1 minus 1. What's the absolute value of 1? Times 2? 2. 2 minus 1? 1. So we have a lot of 1s here somewhere. One last piece. I'm going to grab 0. So we have our y equals 2 times the absolute value of positive 2 minus 1. I heard you. What is the absolute value of positive 2? Times 2 minus 1. 3. If we have set it up right, we should wind up with matching values here. I've got a 3 and a 3. I've got a 1 and a 1 and a negative 1 in the middle. So then what we're going to do is we're going to plot up those points. So plotting all of our points, we have our negative 2, positive 3, our negative 1, positive 1, 0, negative 1, and 1, 1, and 2, 3. I've plotted them in the colors. I did them on the left so that you guys could see it. Absolute values should always be V-shaped. So we're still going to use rulers on these. And we're going to connect up our dots. Always drawing to the edge of our graph. That's trash. There we go. Question on the graph part of this? Let's do our domain and range. What is our domain here? From negative infinity to positive infinity. I could go all the way left as far as I want. I can go all the way right as far as I want. In fact, every absolute value will have this domain. Every single one. How about our range? I agree that part's important with it, but what are my y values that we can use? What's the y value? -1. That's my smallest y value. What is the biggest y value? Infinity. I've got arrows pointing up. I can go all the way up to positive infinity. What's up?
And the absolute value of any number is just like...
It's distance from 0 is the way to think about it. It's how many steps away from 0 is it? Okay, so it's Apple Watch. Steps from 0. We got one more. But questions on this one? Okay. So this is our next one. And we're going to start this one almost exactly the same. We're going to make a table. But we got a whole lot of going on here. And I have stuff inside my absolute value with my x. So we're going to need to be really, really careful when we pick our values for our x's. So there's two ways of thinking of it that give you the exact same answer. So we're going to look at our absolute value, and option 1 is to figure out when this chunk in here equals 0. So when does x minus 3 equal 0? When does x minus 3 equal 0? What would x need to equal? 3. Option 2 is to say, oh, hey, I see that there's a minus 3 in here. And we take the opposite sign. Either way, it's going to give us 3. And that's what we put in the middle of our table. So inside the absolute value is where we find our center. The last two that we did just had nothing in there with the x, which is why we started with the 0 in the middle. What's up, Ricky? Yes. Okay, so we then move on exactly the way we've done before. Some bigger than the 3, some smaller than the 3. What are a couple numbers smaller than 3? 2 and 1. What are a couple numbers bigger than 3? 4 and 5. So this we figure out from this piece here. So just so we're clear, just trying to make sure things color code. Okay, so that's kind of the weirdest part on this. Everything else we do exactly the same. We're going to substitute it in, plug and chuck. So my equation is y equals 1/2 times the absolute value of 1 minus 3 plus 1. Order of operations means we're starting inside our absolute value here. What is 1 minus 3? -2. So now we have the absolute value of -2. What is the absolute value of -2? +2. So we have 1/2 times +2 plus 1. What is 1/2 times +2? Just 1. Plus 1? 2. So my y value is going to be 2. And you do not have to write every single one of those steps out. But if you want to, or if you feel like you need to, you absolutely can. It's totally valid. We're going to do this with the rest of our values here. 1/2 times the absolute value of 2 minus 3. What is the absolute value of 2 minus 3? Because 2 minus 3 is going to give me -1, but the absolute value makes it +1. So we have 1/2 times 1, which is going to be what? 1/2 or 0.5 plus 1. 1.5 or 1.5. I genuinely do not care if you put it as a decimal or as a fraction. I don't care. Even a little bit. It makes no difference. Whichever one of those makes your brain hurt less. Continuing on in our plug and chug journey, we're going to do with our 1/2 times the absolute value of 3 minus 3. What is 3 minus 3? 0. What's the absolute value of 0? Times 1/2 plus 1. So you do not have to write everything out. Sometimes it helps to see what's going on, but other times, once we start getting the flow of these, we don't have to. So now we're doing our 4 minus 3. What is 4 minus 3? 1. The absolute value of 1 is times 1/2 plus 1. 1.5. And we do that again with our 5. Absolute value of 5 minus 3. What is 5 minus 3? Absolute value of 2 is times 1/2 plus 1. So we're just working through this process. We also only have 2 minutes, so I want to make sure we get our sketch in here. So plot up our points. I've got 1, 2, 2, 1.5, 3, 0, 4, 1.5, and 5, 2. So it's going to look like this. There are 2 absolute value graphs on homework 1-6. I am not giving you a new homework today. There's 2 absolute values in homework 1-6. Tomorrow I will talk about finding a more efficient way to do this because holy cow, is this a lot of work. Have a great rest of your day. Happy Monday. Bye. What's up?
I've had enough of Dara. I'm fed up.
I mean, to be fair, she's your friend.
That's fine. It's okay, because when I leave this class, she leaves this class, she got something to come.
Hey, don't make threats. Go make me do paperwork.
That's not what I think when I first seen them.
And they told you what told me out earlier.
I did.
Don't make me do paperwork.
I'm not teaching the words.
She told me she was gonna choke me out. Like,
Don't make me do paperwork.
This is Thursday, right?
What? Oh, yeah, the next quiz, yes, Thursday. All right, let me turn this on. All right. up?
On the 3.3 homework,
Uh huh.
I don't know, like the second half of it, the stuff seemed worded really, I forget like exactly the pages.
Okay, give me a second. I am coming up with a way to get around the fact that my iPad and my computer are arguing with each other. And I've come up with a thing that I think will work. But you're just getting a preview of what we're doing today. Close and capture. That close and capture. Back close and capture. Back close. All right, cool. Then we should DC 9 17. Save.
Take back what I said, I just had a specific question.
Okay. There we go.
So on 7 and 10, it was like use the slopes to
For
improve.
3.2 or 3.1? 3.2. 3 point. Oh yeah, 3.3. There we go.
It was like use the slopes
Mhm.
to prove if it's this type of shape. And I got the slopes,
Mhm.
but I was wondering what would they look like to prove that it was?
Was it parallelogram?
Yeah.
So then you would need 2 sets of parallel lines.
Okay.
Of your 4 slopes, do 2 of them match? Do you have 2 pairs?
Yeah.
Yeah, 2 pairs. That would be 2 sets of parallel lines. That makes it parallelogram.
Okay. So
That's
does
just how
it
we
have
prove
to be like 2 match and then the other 2 match?
Mm-hmm.
Okay. So only one of them matches. I don't know if I did my math wrong.
For number, which one?
7.
Number 7, and that was on 3. Which one do you have that does not match?
From D to A.
D to A. That one should match BC. What did you get?
I got -1/2.
Guys, I was supposed to do
I think you dropped a sign in your
Okay.
numerator.
Okay.
-2 minus 1, we should have got -3
Oh.
over -2. Yeah. I was gonna say, so it should match, but you did it beautifully. All right. This is function. Okay.
Yeah, exactly.
think I
Huh?
you did it first and I did it second. I mean,
No, that's it. Probably gotta wait till next week.
All right. So we've got a definition on the screen for a function. Y'all have worked with functions before. A lot of things we work with are functions. I'm going to mark our attendance and we'll talk through what this is. But this gives you a chance to write it down. Because my iPad and my computer are arguing, so I will be mostly hanging out over here so I can force them to talk to each other. Because they don't want to talk to each other. So, 4, 11. All right.